Hello students, welcome to mathematics class. Students, this is part 4 of the chapter Algebraic Expressions and Identities. In this part 4, we will be learning multiplication of algebraic expressions. Students, multiplication of algebraic expressions broadly we consider, but as a basics for learning multiplication of algebraic expressions, we will start considering monomials and we will see multiplying a monomial by a monomial. Now, when two monomials are multiplied, how do we do? So, let us begin. Now, we begin with the 4 into x, where 4 is a one monomial and x is another monomial. You know, 4 into x nothing but x added to itself by 4 times. That is the 4 into x, which is equal to 4x. 4 into x is nothing but 4x. And you know multiplication fact, how to multiply two numbers. Now you are learning how to multiply variables or algebraic expressions having both numbers and variables. Now coming to the another example, 4 into 3x. What is the meaning of 4 into 3x? 4 into 3x is nothing but 3x added to itself for 4 times, where 3x plus 3x plus 3x plus 3x, you know how to do addition of like terms. When we add, we get 12x. So multiplication is just nothing but repeated addition. Now how do I get this 12x without doing addition? That is 3x added to itself for 4 times. Just if I multiply here 4 with the coefficient of this monomial 3x, you will get 4 3s are 12. So 12 and that variable portions multiplication gives you x. Now observe the following products. One by one we shall take. First one, x into 3y. So x into 3y is x into 3 into y, where 3 I will write first. So 3 into x into y, by associative property I can change the order of multiplication of numbers. So 3 into x into y, so 3 into x into y gives me 3xy. Now let us take another example. How to do 5x into 3y? 5x into 3y is just nothing but 5 into x into 3 into y, where I will take first numbers 5 into 3 into x into y gives me 5 3s are 15 xy as the product. Now let us take another example, 5x into 3y, which is nothing but 5 into x into minus 3 into y, where 5 into minus 3 into x into y gives me minus 15 xy. You know how to do multiplying a monomial by a monomial. It is such a simple thing. Now children, very important, notice that all the three products of this 3xy, 15xy, and minus 15xy, which are the product of monomials. That means product of two monomials will result as a monomial only. So, product of monomials is also monomial. Very important. Product of monomials is also monomial. So, that is one important note. Then coming to the some more examples. How do we do 5x into 4x square? 5x into 4x square nothing but first I will multiply coefficients 5 into 4, which gives me 20, and I will multiply numerical portions separately, variable portions separately. So, variable portions is x into x square, which gives me x cube, and it totally results as 20x cube. Now, let us take one more example, 5x into minus 4xyz. So, first we will multiply numerical portions, that is 5 into minus 4, and variable portions separately x into xyz. Now, 5 into minus 4 gives me minus 20, x into xyz gives me x into yz, x into x is x square yz. So, children, it is easy that we are taking the numerical portion separately and multiplying them, variable portion separately and multiplying them, and when we are having variable portion separately multiplying, the product of a variable by itself for the number of times comes as the power. So, since x is multiplied by itself for 2 times, here you are getting x square. Now, we are actually using the important fact, coefficient of the product, this one is the coefficient of the first monomial into coefficient of the second monomial, and x into x square gives me x cube. Algebraic factor of product is equals to algebraic factor of first monomial and algebraic factor of second monomial. That means variable portion is going to give you the product of variable portion of first monomial and variable portion of second monomial. And children, here very importantly we are using laws of exponents, which you have learnt in your class 7th. So, laws of exponents are very important in this algebraic expressions again when you are multiplying them. Now, coming to the multiplication of 3 or more monomials. See children, when you know a multiplication of 2 monomials, now it is easy to solve or learn or do multiplication of 3 or more monomials. Let us discuss with the examples. Observe the following example. You are given 2x into 5y into 7z. How do we do that? So, if I want to multiply 3 or more monomials, I will choose 2 by 2 first 2 or second 2 or first and third. I can choose in any order because associative property holds true for numbers in multiplication. So, order of multiplication does not matter at all. Okay, it matters nowhere. Okay. Now, 2x into 5y I will do first, then to that product I will multiply 7z. So, 2x into 5y gives me 10xy and 10xy into 7z gives me 70xyz. Now, let us take another example. Now, you are asked to multiply 4xy and 5x square y square and 6x cube y cube. So first I will choose the product of two monomials, that is we have 4xy into 5x square y square, their product gives me 4 5s are 20, x into x square x cube, y into y square y cube. So I got a product as 20 x cube y cube. Now that product I will multiply with the third monomial, that is 26 are 120, x cube into x cube x power 6, y cube into y cube y power 6. This is going to be the answer written like this. So in algebra, we instead of multiplication symbol, we will use a dot for multiplication. Now see children, it is clear that we first multiply first two monomials and then multiply the resulting monomial by the third monomial. This method now you can extend it to the any number of monomials when you are multiplying them. Okay. Now coming to the, is there any alternative to this? Yes, there is alternative. When you wanted to multiply 4xy into 5x square y square and 6x cube y cube, I will take all the numerical portions at a time separately and multiply them. 4 5s are 20, 26 are 120. Then I will take all the variable portions of these three monomials separately. So x into x square into x cube gives me x power 6, y into y square into y cube gives me y power 6. So this is alternative method. Instead of doing 2 separately, at a time you can multiply 3 or more monomials. Now coming to the very important task. Now we will solve this, try this one. Find 4x into 5y into 7z. So if I am multiplying, I will multiply like this: 4 into 5 into 7, next x into y into z. So I am using dot instead of multiplication symbol. So you know how to multiply this. 4 5s are 20, 27s are 27s are 140. Product of x y z comes as it is x y z. So this is the result. So this is alternative method, but he is asking us to do find 4x 5y first. So if I do 4x multiplied with 5y separately and to that product 7z multiplied, 4x into 5y gives 20xy into 7z gives me 140xyz, and he is asking us to do first 5y into 7z, then to that product 4x. So 5y into 7z gives me 35yz into 4x, it is again 140yzx, or it can be written as xyz. So results are same. Is the result is same? Yes. And what do you observe? We observe that associative property is true for the algebraic expressions with respect to the operation multiplication. That's it. Now does the order in which you carry out the multiplication matter? No. So order of the multiplication doesn't matter at all. That's it. So this is the try this. Now children, we will go for some examples from the textbook. Example number 3. Complete the table of area of a rectangle. You know how to find area of a rectangle, children? Yes, area of a rectangle is the product of length and breadth. If we are given length and breadth, we find by multiplying length and breadth. Like showing here, 3x into 5y gives 15xy, which is the result, and that is going to be area. Now similarly, can you find out this? Yes. So 9y into 4y square results as 9 4s are 36, y into y, y cube. Next, in the third one, 4ab into 5bc, 4 5s are 20, a comes as it is, b into b gives b square, and c comes as it is. Now in the last one, 2l square m into 3lm square, 2 3s are 6, l square into l gives me l to the power 3 or l cube, m into m square gives me m cube. These are the areas. So coming to the example number 4. In example number 4, we are asked to find the volume of each rectangular box. Rectangular box means nothing but cuboid. So with a given length, breadth and height. Do you know how to find volume of any cuboid, children? You know, just volume of any cuboid will be the product of length, breadth and height. So here we are given a table containing length, breadth and height in terms of monomials, and you knowing the formula of volume, and we will find volume. How to find? For the first one, I am showing you as an example, volume of a cuboid having 2ax length, 3by breadth, 5cz height will be 2ax into 3by into 5cz. So numerical parts are multiplied. 2 3 is 6, 6 5 gives me 30, and ax into by into cz variable portions product gives us abc xyz, and that becomes the volume. Now for the second one, you need to do it now. So volume will be m square n into n square p into p square m, which is nothing but here no numerical part you could observe, which is actually means 1 we have. So 1 into 1 into 1 becomes 1, m square into m. From this you will get n into this n square comes into p into this p square comes, where that results as m square into m is m cube, n square into n is n cube, and p into p square is p cube. So you have, whether you write 1 or without writing also can just right away write m cube, n cube and p cube. This becomes volume. In the third case, 2q into 4q square into 8, 2 4s 8, 8 8s are 64, and q into q square into q cube is q to the power 6 becomes the volume. So this is the example number 4. Children, now the time to get homework. So homework for you will be exercise 9.2. Take out your textbook. If you don't have textbook, you need to download textbook from the internet, and in the textbook you can get exercise 9.2. There are 5 questions. I'm giving you them as homework. So with this I'll wind up this session. Take care of yourself. Jai Hind. Thank you.